Question 11. There are n beads in a jar. 40 of these beads are black. Takes a random sample of 50 beads from the jar and 5 are black. Work out an estimate for the value of n. So n beads in a jar, so it's 40 beads that are black out of n, and that will have the same proportion as the 5 beads out of 50. So what we're going to do here then is I'm going to times the n up and the 50 up at this side. So I will then get 40 times 50, which is 2000, and 5 times n, which is 5n. So then if we divide both sides by 5, that will then give my n as 400. Question 12. Probability Rebecca wins any game of snooker is P. She plays 2 games of snooker. Complete in terms of P the probability of the tree diagram. This is a tough one. Probability of P, well, the probability that she will lose is 1 minus P. Same here, and the same here. It's the second game, the first game. Write down an expression in terms of P for the probability that Rebecca will win both games. So it's P times P. It's going this way and this way. So this was 12a. So for B, P times by P, and give you P squared. C, write down an expression in terms of P for the probability that Rebecca will win exactly one of the games. So one of the games then, well, one route is win and then lose, the other route is lose then win. So it's the probability of those combined. So it's P times by 1 minus P plus 1 minus P times P. That's enough. Some people may times out the brackets, so you get P then minus P squared, and here P again and then minus P squared. So if you end up with 2P minus 2P squared as well, that's also acceptable, but that alone itself is good enough. Question 13 is always your histogram that's been drawn. Now we're told certain information here, so we're told that you've got 285 farms, and work out an estimate for the number of these farms with an area greater than 38 hectares. This is worth 3 marks. So 38 hectares. So what can we do? Well, there's a few different ways of doing this. If you know you've got 285 farms, the area is worth 285 farms. So what we could do is count the number of squares. That's one method. Personally, I think I will go for that method. So I'd work out how many squares in each of these. So this first one here is 15 squares across, and then 35 squares up. So we've got 525 squares there. This is then 5 squares across, and 10, 20, 30, 40, 49 squares up. So 49 times 5, 245. Then we've got 10 times by then 28, so that's 280. We've then got 25 here by 10, which is 250. That's just an 80 to make it clear. And this one here then, we've got 10, 20, 25, and then that's times by 5, so that's 125. So the number of squares, we add them together. Should give us 1,425 squares. So then we've got that equals 285 farms. So one farm is 5 squares. What I've done there is divide by 285. What we can then do is work out the area that takes up more than 38. So here we've got 2 times by 28. So that's that area up there, just this little area shaded in. So 2 times by 28 gives you 56. And I'm going to have 56 squares to our 250 squares to our 125 squares. Which gives us 431. So we're getting up 431, so we do 431 divided by 5. That will then tell us the number of farms we've got, which is 86.2. So I would round that down to 86. You could round up to 87 if you wanted. Either answer is acceptable. And question 14. Card and it text random 2 of these cards. Work out the probability that there are different letters on the 2 cards. So, what we're looking for then? Probability of A and B. The probability of A and C. And also the probability then of B and C. So if we work these out separately first of all. So we've got A, which is 3/6, and then bearing in mind you've taken an A then, you've got 2 B's out of 5. That'll give us 6 out of 30. We've then got A, which is 3 out of 6, and then times by C, which is 1 out of 5. So that's 3 out of 30. And then B to C, we've got 2/6, and we times that by 1/5, which is 2 out of 30 again. So we've got those values there. Now, is there anything that we've missed off there? Well, let's imagine this was a tree diagram. If you really struggle with this. So A, B and C. There's only 2 on that one because C, if it's been picked, can't be picked again. So you've got A, B, C, A, B, C, and then A and B. So what roots have we got? I've said A and B. So A and B is there, but also you can have B and A, can't you? So we're actually going to times this value by 2, because there are 2 roots on the tree diagram that you can use. A and C, well you can go A and C, but you also go C and A, can't you? So again, you times this one by 2, which will give us 6 out of 30. And B and C, we can go B and C, but you can also go C and B. So again, 2 roots on the tree diagram. So that'll give you 4 out of 30. So if we add the 4, the 6 and the 12, that will then give us a total. So the probability then of different is equal to 12 plus 6 plus 4, which then gives us 22 out of 30, which will then cancel down if you half it to 11 out of 15.